So here they give us marginal revenue. They tell us the marginal revenue, so that means they gave us the derivative function. They gave us the rate of change function. There you go. In billions of dollars is approximated by this expression. Okay, we want to use an integral to help us compute the marginal revenue. And see, when I copied it, the area didn't come out, so you can shade it again for yourself. We want to know what the marginal revenue is from the beginning of 1996 to the end of 2001. But the end of 2001 is really the same thing as the beginning of 2002. Okay, so that's the trick. If you don't change that phrase, then you've used the wrong integrands. If you go through the step-by-step, view this example, or help me solve this. So 1996 is going to be 10, 2, 4, 6, 8, 10. All right, that's an x value of 10. 14, 12, 14, 16 is the beginning of 2002. So your area that you want to find here is between 10 and 16. You don't want to use 15, because 15 is at the beginning of 2000. Beginning of 2001, but we want it to be the beginning of 2002. Beginning of 1996 to the beginning of 2002. So this area you'll have to shade on your paper there. So they've given us marginal revenue. They gave us R prime to be 3.98 plus 500x plus 12 thousandths x squared. If we integrate that from 10 to 16, we will have the total revenue. Add it all up. The whole area under this curve, the area under marginal revenue, is the same thing as finding the accumulation of revenue from year 2000, beginning of 1996 to the beginning of 2002. So that's why that will do that summing for you. All right. So that's the integral that we're going to compute, because they gave us marginal revenue here. That's what my thing was with the chickens problem, because they weren't clear whether that was the way the chickens were changing or was it just strictly chicken production. So depending on what they assumed, maybe the number is correct, but it seems so small. So that's why I'm going to go back and look at that. All right. So can you help me find this antiderivative? 3.98 x. Okay. Very good. 500x squared over 2. Okay. Over 3 x to the third. All right. That's our antiderivative. So we have to evaluate that at 16. Get that number. Evaluate it at 10, get that number, and subtract the 2. No, it's just supposed to be x. There we go. Did you see that? Make sure you fix that. It's 3.98x. Thank you, Maria. 3.98x. When you anti-differentiate, the power goes up by 1. Okay. All right, so let's see what we get. I'm going to hit pause here. I won't have any room to do the extra steps, but we can do it all in our calculator here and see what we get. Evaluate this antiderivative at 16 and evaluate it at 10, and let's see if we get the same thing. I was trying to make sure I did lots of parentheses there. Okay, so Scoot and I match. Ken Maria, yes? Not yet. Anybody else? Gabby, yes? 40.164. Yes. Okay, now let's see. It may have told us at the very beginning, when they have the blank there, what to round to. Really? Okay. So 40 billion. 40 billion, 164 million for total revenue between those two. So that is a lot of just making sure you're calculating. If you have to write it down at each step, write down the whole step where you evaluate at 16. So how far, where was it not being the same thing, Philip, you were working on last night? Okay. That's what we're getting. That's right. That's good. Right here?
Yeah.
Okay, anti-differentiating this? Yeah. Okay. Is it clear now?
Yeah.
Okay. Okay, good. All right, so that's a total accumulation.